or limit. So, depending on this concept, you have some problem. You can see there are some formulas here. I think you already have this formulas. So if you want, you can take a screenshot. And then we can move to the questions. So this is the question 1. Take a minute to solve it and write your answer on the chat box.
Hello.
Yes.
No. Okay.
We need to evaluate. This is all evaluate means is this correct or not?
Yes.
That's all.
Yes. You have 4 different problems. You can consider it as 4 different limit problems. So you just have to solve it and you have to check it whether the left hand side and the right hand side are equal or not. So remember what we did last time, that if there is no problem with the limiting point, then you can directly put the value of the function. If you are facing some problem, then you have to balance the function in a way such that the problem point got removed. Okay, so try to solve it in this way. Then try to find for which option the left hand side and right hand side both are same. Okay, so we have some answer. 1, 3, 1, 3, how 1 is. So I'm giving you 2 more minutes so that you can solve it. All of you can solve it. Then we will start doing it.
Hello, ma'am. Ma'am, how to solve? One hint is a x common or
You can check whether you can factorize the function, or if the function is like not defined at the point. Suppose for the option 1, if at this point the function is this function, the whole function is not defined, then you have to do something, maybe a factorization or what, so that the function become like defined at that point. Okay, then you have to just put the value here and you have to evaluate the limit. Okay, so we have so many options. Many of you are saying that it's 1 and 3. So yeah, we can start solving. For the option 1, it's clear. You can see this function x square minus 6x minus 7, it can be factorized as x plus 1, x minus 7, and this x square plus 3x plus 2 equals to x plus 1, x plus 2. Then we can cancel this term out. And now we don't have any problem with x equals to -1, right? So we can directly put it in the function. So it will be -1 minus 7 by -1 plus 2, it is -8. So option 1 is correct, right?
Okay, ma'am.
Yes,
Yeah.
ma'am.
Yes, ma'am.
Mhm. Okay, so let's look at option 2. So it's clear that at the point x equals to 0, we don't have any problem with the function, right? The numerator is will be -7. If we just put x equals to 0 here, the value will be -7 by 2, right? Which is clearly not equals to 8. So option 2 is not correct. What about option C? Here we have just a polynomial function.
Hello, ma'am. Ma'am,
Yes.
please repeat to question 2.
Question 2 or
I
option?
mean option 2.
Okay. So you can see if we directly put x equals to 0 here, there is no problem with the function, right? It
Okay.
will be a finite point. So at that point, at x equals to 0, the function is defined. So it will be the limit of the function, which is
Yes.
minus
Yes, yes.
7 by
Yes, I understand. I understand.
yeah. So for option 3, you can see this is clearly a polynomial function. So we need not check anything because we know that polynomial function is everywhere differentiable. Hence it's continuous and hence limit exists. We can directly put the value x equals to 2 in this function, right? So it will be 8 plus 16 minus 12 minus 7. We can calculate it. 2, 4, 1. So this is 5, right? So option 3 is also correct. Now let's look at the option 4. You can see here we have a factor x minus 3. So if we directly put 3 instead of x, then it will be 3 minus 3, right? So we will get 0 here. So this is a problem. Now we have to do something such that this problem, such that we can remove the problem, right? So here we have polynomial function. So what should be our first choice? We will try to factorize this function such a way such that this term can be cancelled out, right? This should be our first priority, right? So we will now try to factorize this function. So you can clearly see this we can write as x cube.
Ma'am, it's x minus 3 ka whole square maybe.
Yes. Oh, sorry. Yeah, it's directly x minus 3 whole square. So you can just cancel the term and it will be some limit x tends to 3, x minus 3, right? So this will be 0. And this is not equals to 1. So it will be wrong option. Fine. Any problem with this question 1? Can
No,
someone
ma'am.
tell
No,
me
ma'am.
what are we
Yeah,
doing
No,
in
ma'am.
this joint? Okay. So this is basically solve with a session for the week 7, and we just started with our session. This is the first question. You have to check what are the correct options. Okay. And for that, we need to evaluate the limit for all the options, and we will check whether the left hand side and the right hand side are same or not. If it is same, then the option is correct. Otherwise, it's wrong. That's what we just did here. So this is the first question, and I hope no one having any problem with that. So we can move to the second question. Okay. So this was the solution we just did here. If you want, you can check it. Otherwise, we can move to the next question 2. Yeah, this is the question 2 here. So yeah, take a minute to solve it. Write your answer again on the chat box. You can see, you just observe the graph. Okay, you just have to observe the graph. It's a pretty simple question, and just warning, it can be there maybe more than one correct option. So try to check all the option whether it is correct or not. Okay. So you have 257, 257, 252, okay. Sir, what is our goal? Our main aim, what should we do here? We should observe the graph, right? What is the first option? Limit of the function as x tends to 0. That means as x tends to 0. Here, x tends to 0. So then the function will be tending to 0, right?
Yes, ma'am.
So clearly, this option is wrong, because here they say this is 1. And for the second option, I can see this is correct, right? So option
Yes.
2 is correct. Yeah. Now what is the option 3? Limit of the function as x tends to 0 is undefined. So this is again wrong, right? What is option 4? There is a unique tangent at the point x equals to pi, but not at x equals to minus pi. So at x equals to pi means this point, and we know this is the tangent line at x equals to pi, right? And for x equals to minus pi, this is the tangent line. So we have unique tangent for both the points pi and minus pi, right? So option 4 is wrong. And hence option 5 is correct, right? This is the correct one, right? And what is
Yes, ma'am.
option? The given function is monotonically increasing on the interval minus 0.5 pi to plus 0.5 pi. That means from here to here. Is it?
No, it's decreasing.
No.
We can directly see here it is decreasing. Then
And
it
then
is
increasing.
increasing, right? So this is not monotonically increasing on that own interval. So this option C is again a wrong answer. So what is option 7? The given function is monotonically decreasing in the interval. Is it?
No, ma'am. It's wrong.
So this is again our wrong. So we have option 2 and option 5 as our correct option. Okay. So yeah.
Ma'am, the line x is equal to 0 is the tangent for both of those points, right? Minus pi and the plus pi. So is that unique?
One by one.
Same line is the
I will prick all of your doubts one by one. Yes. Yes.
Ma'am, how come the tangents are unique, ma'am? We have the same line as tangent for both these points.
Yes. So if you are facing any problem with your mind, you can write it on the chat box. I will try to.
Ma'am, she's asking that x is equal to 0 passes through that both points. So how can it be unique? I mean, how can it be unique? She's asking.
Okay, so it's not about that. At this point, this curve has a unique tangent line, which is this. Is there any other tangent line at x equals to pi?
No,
There
ma'am.
is only one tangent line at x equals to pi, right? And
Yes, ma'am.
similarly, at x equals to minus pi, there is only one tangent line, right? This may be same for both the point, but for both the point, there is only one, right?
Yes, ma'am. Okay, ma'am.
Ma'am,
So-
regarding the tangent, in this graph, like in almost all the vertex or the bulged areas, we'll be having a single tangent, right? Let's say, for example, in minus 0.5.
Yes.
Okay. So I'm just trying to understand the concept.
If a graph is differentiable, then it will have unique tangent at every point, okay? Because the tangent in what is the tangent for a graph? This is basically value of the derivative at that point, right? Right?
Okay.
That means the left hand derivative and right hand derivative both are actually same at that point. So we have, if a graph is differentiable, then at each of the point, the tangent line will be unique. So we can see there is, the graph is clearly differentiable, right? We don't have any sharp edge here, right? This type of edge here. So this graph is clearly differentiable. So at each of the point, the graph will have a unique tangent, okay?
Okay. Yeah. Thank you.
So any doubt with the second question?
No, ma'am.
So this was the answer. We can check it. So we did in the right way. The option is 2 and 5. So let's move to the next question. Take your time. These are some formula given here. Using this formula, you can solve this. There are basically 9 problems here. You can take time, just 5 minutes. Then we will solve it, okay? Someone has written, ma'am, please explain option 3. The second question,
Yeah, yes, ma'am. The second question. Undefined means what?
this is undefined, right? Because we got the, as x tends to 0, the limiting value is 0. So this is defined, right? This is not undefined.
Okay,
This is not undefined. Yeah, this is defined. Solve the third question. There are 9 different problems. We can pick one by one. What about option 1? What will be the limit of option 1?
It's true, ma'am.
2.
It's correct.
So we can see we have this, right? So we can solve this. Limit x tends to infinity. And we can balance this function, right? It will be log 1 plus x by x into x by sine x, right? X can be cancelled out. So we can balance this. And hence it will be 2 into limit x tending to 0 log 1 plus x by x. Again, limit x tending to 0. This function, right? So it will be 2 into 1 into 1. This is 2. So option
Yes,
1
ma'am.
is correct. Yeah. What about option 2?
False.
Wrong, ma'am.
Wrong. Incorrect.
You are
Correct.
saying option 2 is wrong. This is
Incorrect.
undefined. Yeah. We can see the value is 2. Hence, obviously it is defined, right? So option 2 is immediate from option 1. What about option 3 then?
Wrong, ma'am.
It's also wrong.
Wrong.
Incorrect.
So
Fourth is true.
we can balance it as like that, right? So it will be 1 into 3, hence it will be equals to 3. So this is again wrong.
Option 4 is correct, ma'am.
Yes, correct.
Option 4 is correct. This is correct.
4 is
Yeah.
correct.
So we have option 1 and option 4 correct. What about option 5?
Wrong.
Again, clearly wrong, right? This we can balance. It will be 5. Right?
Option 6 wrong.
Option 6. Okay. So what I can do with option 6, we can again balance it. X by 5 minus 1 by x by 5 into x by 5 by sine x. So this x can be taken here. Okay, it was sine 5x. So 5x will be 25, right? So it will be 1, 1 and it will be 1 by 25. The answer is 1 by 25, right?
Yes, ma'am.
Yes.
Okay. So here they give that this is 1, so this is clearly incorrect. Option 7 is also incorrect.
Also wrong.
Option
But
8
option 8 is
8 is correct.
correct.
8 is correct, yes.
And option
Third
9
way is El Hospital's rule.
clearly. Yeah. So now option 9 is also incorrect, right? So our
Yes.
correct options are 1, 4 and 8. Right?
Yes,
Yes.
ma'am.
Yeah, any doubt? I don't think you should
No,
you
ma'am.
shouldn't have any doubt. Yeah.
Yeah, ma'am, it's clear.
Okay.
How option 9 is wrong?
Because we found the value is 1 by 25. Where they have given that it is 1 by 5. Okay.
Yeah, all right.
So the option is 1, 4 and 8. Yes. Here again we have some formulas. Here you can note down the formula and then solve this question. Your target should be like using this formula, you have to solve this question. So try to form this problem such that it will be in this pattern.
Okay, ma'am.
Why my answer is coming infinity. Okay. try to check your steps. Maybe there is some mistake. If someone got 5, let us wait for 2 more minutes. Let others solve it. Okay, so we have 2 answers. One is saying 1 and another one is 5. So let us solve it. So what can we do with this factor? We can see, we can bring this factor in this form, right? In this form. So here we have something x tends to 0, then value of this, right? Again, we have here 6 by n. So if n tends to infinity, then 6 by n will be tending to 0, right? So we can bring this function in this way. So for this, we have to balance this function as 6 by n, and here again n by 6, right? And for this,
Yes, ma'am.
yeah, for this factor, again we can bring this factor in this form, right? By
Yes, ma'am.
multiplying and dividing with 1 by n, right? Similarly, this we can do here, x factorial, n factorial, 1 by n into. So this term you can actually check here, right? Right?
Ma'am, it is different, maybe.
1 by something, sorry, 1 by something.
It
That
will come
means
the same. It will be e by n.
Yeah.
X n by e.
Yeah, we can do this also, like we can this, and then we can multiply this n factorial into 1 by n, right? Then we can bring it here. So what will be the?
Can you explain this once more?
Yes. Okay. So clearly this form we can take it in this pattern, right? With
Yes, ma'am.
multiplying it and dividing it by 6 by n because of this fact. This factor also we can do, like translate it in this form, right? Again, we are multiplying and dividing it with 1 by n. Correct? And again,
Yes.
with this form, we will divide it with n factorial to the power 1 by n. Again, we will multiply it with n factorial to the power 1 by n. Right?
Yes, ma'am.
Yes, ma'am.
Yeah. So just adjust it. There is no enough space, so we can check it. See here what they did. They are balancing this term, right? This is what I just told, right? We are just balancing this term. Then we will put the limit. Okay. Now this is the simplified version. And now we will put 1 by n equals to x. Then as n tends to infinity, then x will be tending to 0. This fact, what I just said here, this fact. Okay. Then we will just calculate it. This. So again, this value is 1, this value is 1, this value will 1, and this value will be 1. E. Sorry. Yeah, this value will be E. So then we can calculate it, and then after simplifying, we will get 5. Fine?
Can you please scroll up?
Yeah. And if you have any doubt, you can ask it. This is clearly, they are just balancing the term to get this respective forms. Then after simplifying, we will get this equation, and then we will apply this function limit e to the power some n equals to e power limit n. This was one of the formula, right? Right? Here we are doing.
Yes, ma'am.
Here we are just doing this one. So then we, after simplifying, we will get 5 as a result. So any doubt?
Ma'am, could you please explain how did 6 by n by n factorial in the root came? Could you please explain that again, please?
There was something outside the bracket, right? This one, this term.
So, ma'am, okay, nothing. I got it. Yes, ma'am. Understood.
You got it, right? So 1 by something. That means this, right? Here they just did, they took this term and put this term here. Okay?
Got it, ma'am.
Yes, ma'am. Yes, ma'am. Got it.
So I don't think you have any doubt with this question. So we can move to the 5th question. Yeah.
Yes.
This is visible, right?
Yes, ma'am.
Yeah. So try to solve the question. Again, you have to find the limiting value of some function. Depending upon the value, we have to do this.
Is this not the graded question?
Yes.
It's a part of graded assignment question. Is it identical?
Yeah. This is not part of graded assignment question, I guess.
It is. Question number graded 7.
Okay, it may be.
I
It may be the same, but I really don't know.
That's okay. I mean, you keep repeating the questions, I suppose.
Okay. Okay. So what we have to do here, we have some 3 algorithms given here. Then what is the part here where n belongs to n minus 0? Here they took basically n as n naught, right? So that is why n belongs to n minus 0. That means 1 to ... infinity. So suppose the company has a large amount of data in hand. So large amount of data in bracket dimension we can assume as n tends to infinity. So based on this hint, we have to solve it. So what should be our first intuition? That we have to evaluate this 3 limit, right? An limit n tends to bn limit n
Ma'am,
tends
fourth
to
and fifth are correct.
Okay, so let us see. So we will first our target is to evaluate these three limits. So what is the limit for A? What is the limit for N? We can balance
0.166.
Okay. So we can balance this at like this.
1 by
Like
6.
1
By 6.
plus 5 by n
By 6.
plus 6 plus 1 by n square, right? If we just divide with 1 by divide with n square, then we will get this term, right? Now if we do n tends to infinity, it will be 1 by 6, right?
Yes, ma'am.
And what is the value in point?
0.166.
0.166. So what about the B?
Fourth
0 tends to
option.
infinity, B. So it will be 0, right? This term will be 0,
Yes,
right?
ma'am.
So it will be 1 by 8. 1 by 8 is approximately
0.125.
0.21.
this. And what we see, again we can do
1/7.
4 to the power minus n by 7, right? Sorry, e power
Yes.
minus n by 7. So it will be 0 and it will be 1 by 7, which is approximately
0.142.
142. So we can see this is the maximum number, right?
Yes,
Right?
ma'am.
So what is our first is error estimated by algorithm 1 will be the maximum error.
Maximum error.
So this answer is clearly correct, right? We are getting the maximum error here, right?
Madam,
And
the third function, can you just explain once again? I missed it. Cn.
third function. Okay. So you can simply write it as 1 plus 4 into e power minus n by 7. We are multiplying both with e
Okay.
power minus n.
Yeah,
Okay.
got it.
When
Yeah,
n
got
tends
it.
to infinity, this term will be tending to 0, right?
Yeah, correct.
Then we
Got it.
will get 1 by 7.
Thank you.
Ma'am,
Yes.
why option 1 is correct?
Because we have for an, sorry, for an, we have the limiting value is 0.166, right? For bn, we have the limiting value as 0.125. And for cn, we have the limiting value as 0.142. So this is the maximum number, right?
Oh, okay, ma'am. Yes, ma'am.
Among these three, this is the maximum number. So option 1 is correct.
Yes,
Now,
ma'am.
what
How
is
did you
actually?
how did you put minus 1 to the power n by 1 by n as 0? Is it a
1
rule
by
or?
n is 0.
Oh, right. 1 by n is, sorry. Yeah.
1 by n is 0, right? And this term is bounded. This term is bounded, right? So no problem with that. If we have some bounded term and then something which is tending to 0, then the multiplicative term will be tending to 0, okay? So what about the second option? Algorithm 3 will be the minimum error. Is it? Is it the
No.
minimum? No,
No.
clearly, right? This is the minimum, right? So this is again the wrong. And what is option 3? Both algorithm 1 and 2 will give the same error. This is
No.
the wrong, right? Because these things are not same. So this is again a wrong answer.
Also wrong. Yes, ma'am.
Yeah. So what is the value of n? This is 0.166. So this is correct, right? We got
Yes, ma'am.
the error. And algorithm 2, this provide the error
Correct.
0.125. So this is the correct. So we have 1, 4 and 5 as the correct option, right?
Yes, ma'am.
Yes, ma'am.
So yeah, this was the solution and these are the correct option. So that's all. Now we can pick your doubts. If you have any doubt, you can ask it, then we can solve it. is e power n also equals to 0? E power n is never equals to 0. If n tends to infinity,
Minus.
then e power minus n will be tending to 0, okay? Because if n tends to infinity, if we have n tends to infinity, then e power n will be again tending to infinity, right? So 1 by e power n will be tending to 0. This is what e power minus n. So if you have any doubt with this session, you can ask it. Otherwise, if you have other doubt with the concept or anything else, assignment problem, practice problem, then you can take a screenshot and put in the group. Otherwise, we can end this session.
Ma'am, I have a small doubt regarding increasing sequence and decreasing sequence. Can you explain it?
It's same as increasing function and decreasing function. So do you know what is increasing function and decreasing function?
As n tends to infinity, if it approaches 0, it is a decreasing function then. Something like that.
Yeah, so we have a formal definition. If for n plus 1 greater than xn, if the function satisfies that plus 1 greater equals to f of xn for every n, for every point of the domain, then we will say the function is increasing. Okay. If xn plus 1 less equals to f xn, then we will say the function is decreasing. Okay. So this is the formal definition for increasing and decreasing function. And again, you know, a sequence is a particular case of function, right? When the domain is particularly the natural number. When the domain is particularly the natural number, then this kind of function will be a sequence, right? So the concept is basically same.
So we just have to look at the increasing function or decreasing function, then determine if it is increasing or decreasing sequence.
Yes, yes, yes. Sequence is nothing but a function, okay? Where the domain is particularly the natural number.
Okay, ma'am. Thank you. Got it.
Yeah. So someone has posted some question. Consider the function. We have a function given here, f of x equals to x plus by x. So what are the following options correct? F is injective function if the domain is so yeah, I think everyone can everyone see this function, see this question?
Yes.
Yes, ma'am.
Okay,
Yes,
so
ma'am.
what
Yes,
will
ma'am.
be the option 1? What will be the option 1? What will be the option 1? Is it injective?
No, I guess.
Why?
No. Because it will be
Because
the real
it's a
line.
quadratic.
It won't be.
It cannot be quadratic. It cannot be 1 to 1.
Yes, it's x square plus 1 by x. So
Yeah.
Yeah, it can't be injective for real, but it can be injective for natural numbers.
Natural or integer minus 0.
In that region, yes.
yes.
Restricted domain.
But it will
Yeah,
not work for integers. But the thing
When
is, if
the
we take
domain is
1
r
comma
minus
minus 1,
0.
ma'am, it will not work for integers because the thing is, for 1 and minus 1, the output will always be 0.
Yes, correct. So this is the particular example. F of 1 is, sorry, 1 and minus, okay.
Yes, ma'am.
No, this is not working here. For f of 1, it is 1 plus 1, right? This is 2. And f
Oh,
of
yes,
minus
ma'am.
1
Sorry,
is
ma'am. My mistake.
1 minus 1 is 0. This is
One by
clearly
six.
not equal. So any other option? Do you have any other option? Any other example? Try to think.
It won't work on 0 as well because 1 by 0 is infinity.
We are not including 0 in our domain. Okay? We are just excluding 0 from our domain. So if we are
Yeah,
taking
so
r minus 0, yes?
but we can't take r minus 0 because minus 1 would come in that.
No, we are taking r minus 0 as our domain, right? So except the point 0, the function will be defined everywhere, right?
Yes, ma'am.
Yes, ma'am. So it
again,
is injective.
Try to think.
Ma'am, at x equal to 2 and x equal to 1 by 2, f of x would be same.
Yeah. Yes. Very good. Very good. We have to check this we have, right? We can take
Yes,
any
ma'am.
this kind of
X
point.
equal to 0.266.
And 1 by x. X not equals to 0. So this will be basically same, right? Right?
Yes, ma'am.
Clearly this is same. But
Yes, ma'am. Yes.
when we are taking natural number, this cannot be done in this way, right? Because 1 by x will not be in natural number or integer, right?
Yes, ma'am.
So option 1 is wrong. Clearly we found a example and option 2 is correct, right? So yeah, again they said if is injective function in the domain of f, if the domain of f is q minus 0. So again this is not possible, right? This may be in q. This example from a rational number, right?
Yes, ma'am.
Yes, ma'am.
So the option 3 is again wrong. What is option 4? Is it true?
No, ma'am. Again, same
No,
problem.
ma'am. Yes, ma'am. False.
Is 1 by 2 belongs to z?
No, ma'am.
Yes.
Sorry. Yes, ma'am. You are right, ma'am.
So for 4, again, we don't have any problem. What about the fifth option? F is surjective function if the domain of F is natural number and the codomain of F is rational number. Is it
0 is
surjective?
not excluded from that.
0 is not in the natural number. 0 is not in the set of natural numbers.
Ma'am, but in many lectures there was that 0 is included in natural numbers.
Then
No,
I
in this
think
week.
then they will denote this natural number set of natural number as n naught. Okay.
No, ma'am. In this week, actually, natural numbers exclude 0. They have
Yes.
pointed it out.
Yes.
Yes, ma'am.
So actually the natural number is excluding 0. It will start from 1 to so on. Okay. If you have 0 in
Got
the
it,
set,
ma'am.
then you will get something like n naught or else. So for now, you can consider 0 doesn't belongs to the set of natural number. Okay.
Okay, ma'am.
So what will be the fifth option? F is surjective function if the domain of F is natural number and codomain of F is integer.
No, ma'am.
We can take negative point, right?
Codomain cannot be integer.
Codomain is Q. Sorry, my mistake.
Yeah.
Rational.
Yeah, real.
So the negative rational points are also there are negative rational points, right?
Yeah.
But it's clearly not possible to get any natural number such that the sum will become something negative, right?
That's okay.
So this is clearly not surjective function.
Yeah,
If it is surjective, then for every point in the range, we will get some point in the domain such that the functional value of the point is that point, right?
Yes, ma'am.
Yeah. So we can clearly see there are points in Q for which we don't have any pre-image for those points, right? For any negative rational number, we don't have any pre-image, right? So the function for which n is the domain and q is the codomain, this is not surjective, clearly, right?
Yes, ma'am.
But if we take z minus 0 as our domain, then what will be?
0 is a domain, okay.
Then it would be because integer can have negative values.
Yes.
It does.
So if we take any arbitrary point from our integer, so there will be some x belongs to z minus 0 such that f of x equals to minus p by q, right? That is x plus 1 by x equals to minus p by q. Then we can solve this equation and we can find the value for x, right? X square plus some p by qx plus 1 equals to 0, right?
Yeah.
We will get some qx square plus px plus q equals to 0.
Okay.
From here, we can get the value of x minus x minus p plus minus root over q square minus 4q square by 2q, right?
Yeah, no, that's okay.
So, is there any guarantee that this term will be greater equals to 0? Is there any guarantee?
No, ma'am.
No, ma'am. No, ma'am.
Which
So what
domain we are
can
now? What is the domain for this?
Integer except 0.
Integer.
this PQ, we know that this PQ belongs to Z and Q not equals to 0.
0.
So is there any guarantee that this term will greater equals to 0?
No, ma'am.
No, ma'am. No, ma'am.
There are.
There is guarantee?
Yeah.
How?
You
We
just
can take
x plus 1 by x, if you plot, it comes from the minus infinity, goes down to minus infinity at 0. So
if we take P equals to 1 and Q equals to 1 belongs to rational number.
No, then it will be imaginary.
Then
it is imaginary. If you're taking a P and a Q equal to 1, then obviously it will be imaginary.
it will be imaginary, right?
Yeah.
Yes, ma'am.
So for the point 1, we cannot find any pre-image, right? Is there any point such that the image is 1 in Z minus 0? What do you think about it? If I just take 1 from Q, is there any point which can be the pre-image for 1 from this domain?
No, ma'am. There will be none.
Clearly no, right?
Yes, ma'am.
Because if it is the pre-image, then it should satisfy the equation. Then it will be something negative and it will be a complex number, right? So according to me, the last option is also not correct from this steps. So any problem, any like confusion?
No, ma'am.
Thanks, madam. Like I had posted that question. I had a doubt in the last two options. Now it's clear. Got it.
Yeah. Okay. So I think this question is clear to all of you. Now we can move to the
Yes, ma'am.
next question. So we have this question: n tends to infinity, n e power 1 by 10 n minus n. This was the question, right?
Yes,
So this
ma'am.
is, I think this is a pretty simple question, right? You should do this on your own. We can write it as in this form, right? Then just do this multiplication and you will get 1 by 10 limit x tends to 0 e power x minus 1 by x, right? So this is
Yes.
right. This was a pretty simple question, right?
Yes, ma'am.
Yeah. So what you have to do, you just have to remember all the formulas. Then you have to bring the question in some of the format so that you can apply the formula, right?
These formulas will be given along with questions or not?
I don't
Not,
think the
not.
formula will be given along the question. You have to keep it remember, okay?
So it's like sin x by
You have
x
to keep it
and
in your
log
mind.
1 plus x
I
by
don't
x.
think they will give the formula also.
Okay.
There are max to max 8 to 9 formulas that you have to keep it in your mind. So if you start practicing this limiting problem, then it will be used to. So don't worry about that. Okay, so we have consider the sequence AN. Here we have a sequence AN, n equals to 1 by n, which is known to convergent to 1. Okay. So what will be the limiting sequence Bn equals to n power? I think it's 6 by n plus 9 n power 1 by n. Okay. So we have limit n tends to infinity n power 1 by n equals to 1. Now we have to find limit n tends to infinity Bn.
14.
Really, have I to do it? I think I don't have to do it. You can or do it your own, right? What is the answer? What is the answer?
9.
9, right?
9.
Yes, ma'am.
Why?
1 power 6 plus 9 into 1 minus 1.
So we can just simply break it. Minus 1, right? So this value is 1. What about this value?
1 power 6.
Okay. What about this value? We can simply write it as n tends to infinity n power 1 by n power 6, right? So this is just 1.6, like this is 1. So we have 1 plus 9 minus 1. This is clearly 9.
9, yes, ma'am.
Okay, so again we have given some sequence an and some sequence bn. So we have to find the limit for the sequence. So you will solve the problem. We have n as 4n plus 4 by 39n plus 15. What will be limit n tends to infinity an? What is the value? What is the value?
4 by 39.
Yeah, this is clearly 4 by 39, right? Now we have Bn equals to 5, 9.
Ma'am, in denominator, you have written 39n.
This is 39. Yeah, this is
Oh, okay,
39
ma'am.
n multiplied by n, not to the power. (20n square plus n cube plus 1). So yeah, find the limiting value of this sequence. What will be limit n tends to infinity Bn? We just have to do the calculation, right? Nothing else. And
Okay,
you
ma'am.
can use your
It's just the
calculator.
substitution of A and ma'am over here.
Yeah, sure.
Okay, ma'am.
You can put it directly here. You can calculate it. I'm not going to calculate it. So it is n plus 1 by n square, right? So it will be 0. This term will be 0, right?
0.
This term is clearly going to 0. So you have to do this calculation. Okay. There are this problem. Why do you have doubt in this problem? We have given the
Ma'am,
function f
we
and
don't
g,
have
right?
a doubt. It was a backend issue. I mean, it is a backend issue.
This
The
problem.
answer is showing is not in this problem. It is given bracket fg equals to
Yes.
bracket
So
0.
if you
So
have something
in
like
that,
that,
the answer is coming as 2, but it is given as 6.
Where
Not in
is
the
you have
sub
given
part
it.
of this.
So this is f of 2 by g of 2, right?
Ma'am, the second
Yes,
question.
ma'am.
Second part.
3 into 4. Okay, like 3. Third one.
Yeah.
Third
It
one.
is coming as if we do it
F of
fx
g
into
of 0
gx.
means f multiplied by g of 0 means f of 0 into g of 0, right?
But that is not the answer which is given. Like we are getting it as 3, but in the
Yeah.
backend it is given as 6.
Okay.
You find FOG, you'll get the answer.
Yeah, FOG if you do, you will get 6. So either in the question, it should be FOG.
They should mention it whether it is f compose g or f multiplied by g. So if it is f of g, then it will be f of 1. This is 1 plus 2 plus 3. Yeah. This is 6.
Where are these problems?
7.2 activity questions.
7.2.
Okay. So they should have mentioned if it is the composition or it is the multiplication. If it is composition, they should use the composition sign here.
FOG.
Yeah, there may be some silly mistake. Don't worry about it.
Yeah,
So
ma'am, it's a mistake.
yeah.
Because
If it
during
is,
PS sessions,
if
they
we are
had
a
explained.
composition, then they should put the composition sign here. This sign, okay?
Yes, ma'am.
If it is in that form, then it is a multiplication of function. There may be some silly mistakes, so don't worry about it. So I can't see any other problem here.
Yeah, ma'am, that's the problem only.
Yeah. So is there anything to ask or what?
Ma'am, I
Ma'am,
just
can you
posted one.
share?
Ma'am, this means this is supposed to be F composite G.
Yes, if they really mean if compose G, then they should use this notation. Otherwise, it is this notation usually means the multiplication of function.
Okay, ma'am.
In the exam, we will clearly mention whether it is multiplication or it is composition. So don't worry about it.
Okay, ma'am.
Ma'am,
Yes.
I had a question in the I just posted a question in the chat. In that third option was the one confusing for me. I was thinking it's to be 1.
Okay, so what was the question? We have a function given here, f of x equals to 1 when x greater or equals to 0 and minus 1 when x and 0. This is the function we have given here, right? So if x we're taking if x tends to 2, then clearly 2 is greater than 0, right? This value should be 1 then, right?
Yes.
So we can
Okay.
draw the function even, right? For x greater or equals to 0, the function is this 1.
So step
And for x less than 0, this is this. It will not touch the x equals to 0 line, right? It will not touch the x equals to 0 line. So clearly, when x is going to 2, here suppose this is 2, then the functional value will be 1, right? So the limit will be 1. So the first option is not correct. So when x is going to 0, from the positive side, if it is going to 0 from the positive side, then the value will be 1. But if it is going from the negative side, then the value will be clearly minus 1, right? So the left hand limit and right hand limit are not equal for the point 0, right? At
Okay.
the point x equals to 0, the left hand limit not equals to the right hand limit, right? So basically at the point 0, limit doesn't exist. And what we know generally for a step function, the limit doesn't exist at this point, that breaking point, right? So at the point x equals to 0, the limit will not exist. So when x tends to minus 0.5, minus 0.5 will be something here, right? When x tends to minus infinity, from the positive side or negative side, doesn't matter. The value will be minus 1, right? So option 3 is correct. And left
Okay.
hand limit, when we are tending from negative side of 0, then the value is minus 1. And when we are tending from the positive side of 0, from this side, then the value will be plus 1, right?
Yeah. Plus 1.
So the
Correct.
next answer is correct. And after this is the wrong answer, right? The fifth option is wrong. And the sixth is again wrong, right? Because they have told limit x tends to 0 plus fx doesn't exist, but it exists. Right hand limit and left hand limit both exist, but they are not equal here, right? So this option is again wrong. Then the next option is limit of the function at 0 doesn't exist. This is correct, right? Because of this. Limit of the
Yeah.
function doesn't exist at any real number. This is wrong. Clearly, except 0, the function except in this domain r minus 0, limit will exist, right?
Yeah. Got it. Yeah. Thanks.
Ma'am, in the last option, you said that limit for the value tending to 0 will not exist. But we have that value x greater than or equal to 0, ma'am.
Yes.
So, ma'am, in that case,
When
it should
we are
exist.
tending, when we are tending to 0 from the positive side.
Yes, ma'am.
Let me use another color. When we are tending to 0 from the positive side, that means from this side, right?
Yes, ma'am.
Well, then the functional value will be, then the limiting value will be 1, right? But when we are tending to 0 from the negative side, then what is the limiting value? Isn't it minus 1? Will be minus 1, right? Left hand limit is minus 1 at 0.
Ma'am, why are we looking at both the limits? Shouldn't it be just for the RHL?
No. If we want this domain is right for a whole real number, right?
Yes,
So
ma'am.
if you want that the limit exists at some point, the both left hand limit and right hand limit should exist and they should be equal to at that point. Otherwise, we cannot say that limit exists at that point. Okay.
Okay, ma'am.
Ma'am, it's the fifth option correct?
Yes.
Is the fifth option correct?
I just discussed it. I actually forgot. So the last option is not correct. The second last option was correct. Then the first option was wrong.
Ma'am, the second, fourth, and the second last were correct. So,
Second, fourth, and second last. Yeah, I actually forgot. So you can note it down. Yeah. So if you have any other doubt, you can post it.
Ma'am, so
No,
similar
for
problems.
week 2, the syllabus will be from beginning to week 8, I guess. They will cover from
Yes, ma'am.
beginning-
1 to 8.
Yeah, not from 5 to 8. We
For
will
maths,
mainly focus on the week from 5 to 8, but the whole from first week to 8 with the syllabus include. Okay. Practice assignment.
okay, ma'am.
Can you share the PDF
From 1 to 8.
right
Yes.
now? What
Is
you are
it?
talking?
Yes. Yeah. Can you repeat?
Can you share the PDF, ma'am?
Yeah, I will. For today's session.
Yes, ma'am.
Okay, I will share the video. So if you have any doubt, you can ask it.
Ma'am, I think there's a message in the chat citing some
Yeah,
questions.
someone is saying practice assignment 8, 9, 10. I don't have the practice assignment along with me. I don't remember what was the question. So what you can do, you can take the screenshot and you can share it here so that I can check it.
Can I make a request?
Yeah, sure.
I've been attending other sessions, statistics,
Okay.
CT. And many students are asking what is the portion for the next quiz or whatever is a term. There should be a common policy. I don't know why. Somewhere else I heard it is only for week 5, 6, 7. You said from 1 to 8. So students should be aware what they are going to be tested. As a course,
Actually, the thing is, it depends on the course. It
you are
depends on the leader of the particular course. So for our course, it will be from week 1 to week 8. Okay, for maths 1, it will be week 1 to week 8.
Then
It actually varies. There is no problem with that.
I agree.
This
Have
is
variation, put it
basically
in the
ideal
website.
system.
Put it in the website so that people, there may be a student who
Yeah, we can do
actively
that.
participating in another group. He may not be attending the classes, and he probably will not be prepared for a week 1 to 4, and he will be in a shock. You understand? See, basically, this kind of interactions probably enlighten the student about the portions. Otherwise, as an educator, I think it should be in the website. Look, these are the questions, or these are the portions, so that they are aware of.
Okay, I will ask.
Please pass this feedback.
Yeah. I will surely ask this to post in the website.
As a policy through the foundation, it will be cumulative, no problem. Somebody says, no, it is 4 to 5. Those kids will probably be preparing only from 4 to 5, and then they will be doing it for all the courses, all the subjects. And they will be in a shock when you ask about something in the first.
Yeah, sure. I will definitely ask them to put it on the website.
Either it should be uniform. If there are variations, it should be at least in the.
No, but this need not be. This need not be uniform. This may vary according to the dependent on the
I'm
course.
not asking it to be uniform. If it is not, variation should be at least communicated.
Yeah. I will definitely ask them to put it on the website. Will definitely. Okay. So Yeah. I just shared this PDF. You can check it.
Madam, I see that the
Thank you,
question
ma'am.
is listed there, the practice question.
Yes. Someone has posted the 9th question. In this question, there are some function P1, P2, P3. I think you should have any introduction about this function, the definition of this function. So it would be better if you can share. Okay, you shared it.
Yes, ma'am. I have shared the pics.
Yeah. So we have the P1 function as 100 floor function T plus 200 oh, sorry, they are different functions. So these are the three functions we have given. Now, what is the question?
Ceiling. Okay.
Tangent of the function P1 with respect to scheme A doesn't exist at 1. Okay. So you have to check at the point 1, what is P1? This is clearly 300, right? P1 of 1, sorry. And we are taking if x less than 1, suppose greater than 0, what will be P1 of x? It will be 200, right?
Yes, ma'am.
And if say for same x, sorry,
Can I say something?
yes,
It involves a floor function, right?
yeah, this is a float
Floor
function.
function will always have a discontinuity at integers.
Yes.
It is continuous between the integers. It is discontinuous at the integers.
Yes.
Since the question is at P1, I mean, whatever is that value is going to 1, it will be discontinuous.
Yeah, it will be discontinuous, right? That is what I'm trying to like show, because all of you are not aware about it. Maybe I'm not sure. So that is what I am trying to do here.
What you do is you take the example of a floor function and ceiling function. Just say that they are discontinuous at the
We're
step.
just doing this thing, right? We are just doing this thing.
Okay, good.
I'm just checking the point at x equals to 1. This is some arbitrary integer point. I'm trying to like check that this function will be discontinuous at that point. This is what I'm doing.
Thank you.
Yeah. So if it is the x is something greater than 1 and less than 2, then what will be p of x? It will be 300 again, right? Right?
Yes.
So what we have for at x equals to 1, if I tend from x, if I tend x tends to 1 from the negative side, then the limiting value will be 200, right? And if I take x tends to 1 from the positive side, then the limiting value will be 300, right? This is a constant function, so nothing to put. It will be directly the limiting value. So clearly the left and right limit and right hand limit is not equal. So for every integer value, the left hand limit and the right hand limit will be unequal, right? So limit doesn't exist at 1, right? Hence, the function is clearly not differentiable at that point. And if it is not differentiable, then tangent doesn't exist at that point, right? For any integer point, there will be no tangent, okay? What about the second option? What is the second option? Isn't it I just told now? The tangent of the function P1 which represents the scheme A does not exist at A for any natural number A. For any natural number, the limit will not exist, right? Hence, the tangent will not exist, right? So
Yes,
1
ma'am.
and 2, both the options are correct. Option 3, P3 okay. So for P3, this is clearly a polynomial function, right? And we know polynomial function is everywhere differentiable infinitely many times, right? So at 1, there will be the derivative and it is unique. Hence, the tangent exists at 1, right? And for the P2 function, again, we can do the same thing, right? Again, the tangent will not exist for any natural number in this similar logic, right? So the third option is not correct, then the fourth option is correct. Okay. Any other doubt? Any other doubt?
No, ma'am.
Um,
Ma'am, in this question, the third option, that expression, can you just repeat it, please?
The third option is the tangent of the function P3, which the third option is basically saying that tangent will not exist at the point x equals to 1. So this is clearly not correct, right? Because P3 is the polynomial function, simply a polynomial function, linear function, more specifically. So it will be everywhere differentiable. So at P equals to 1, the tangent will exist, right?
Okay, the option is does not exist. Okay, got it.
Yeah, so it is basically wrong. So again, you are confused with the quiz 2 syllabus. So what I know, the quiz 2 syllabus is from week 1 to 8, not from week 5 to 8. I will tell them in our next meeting to update it in our website only, so that you will not face any kind of confusion here. But for maths 1, the syllabus will be from week 1 to week 8. Okay. So if you have any doubt, you can post it. Otherwise, you can leave.
Ma'am,
Yes.
ma'am, when we will get mock test? Ma'am, when we will get mock test so that we can practice for quiz 2?
Okay, that is, I'm not sure about it.
Okay, ma'am. Ma'am, because time is less, ma'am. That's why I
Yeah. So
asked.
what is your quiz to date? What is your quiz to date?
Ma'am, 4 August.
Okay, 4th August. Yeah. Then we will get it soon. Obviously, we will get it soon. Don't worry about it.
Okay,
We
ma'am.
will get it soon. Don't worry.
Okay, ma'am.
Mhm. Uh, So I think you don't have any doubt.
Ma'am, there's a question. I'll just resend it.
Yeah, sure. Okay, so this is the question. If from A to B be a function, A, B are finite subset of R, which of the following option are correct? The cardinality of gamma F. Gamma is F is basically the graph of F, means x comma fx. Okay. So what we have a function F from A to B. So what is gamma F? This is graph of F, right? That means this is basically x, the movement of the point x comma fx such that x belongs to A, right?
Yes.
So basically, here we have all the x from A, and with this, so is the cardinality of gamma F same as the cardinality of A cross B? Is it? What do you think about it?
No, ma'am, because the thing is, not all values are mapped to
Yes.
all values.
Yes. Clearly, if F is a function, then for each point of the domain, we have a unique image, right? And in A cross B, if we take the Cartesian product of A and B, then it will include all possible combination, right? So clearly, this is not the correct option. So option 1 is clearly wrong. The cardinality of gamma is the graph of F same as the cardinality of A. This is clearly right? Because for every x belongs to A, for every x belongs to A, we will find some point x comma fx belongs to gamma f, corresponding point, right?
Which is the question we are discussing?
It is the last question someone has posted.
Okay.
Ninth one. So this is clear, right? And the third option is there is no guarantee that the cardinality of gamma f is equals to the cardinality of B, right?
Yes.
And the fourth option is it is less than or equal to a cardinality of A. So this is clear, right? Cardinality of gamma f, this is less equals to the cardinality of A cross B, right?
Yes, ma'am.
This is fx
Yes, ma'am.
belongs to B. So this type of combination definitely belongs to A cross B. So we have that gamma of A, this is a subset of A cross
A cross B.
Yeah. So the cardinality will be less equals to the cardinality of A cross B. So the second and the fourth option are correct.
So it is less than or equal to. Why don't we say it as less than only, but equal to is also there? Why?
There may be some example, right? There may be some example for which if we take some 1 onto function. If we take
Ma'am,
it has some 1
ma'am,
onto
if
function.
the domain and co-domain both are having only one value, then that becomes equal to also.
Yes. There are so many examples. If we take A and B, and if we take some 1 and onto function. Suppose A is 1, 2, 3. B is again 1, 2, 3. And from A to B, we're taking F, such then 1 is going to 1, 2 is going to 3, and 3 is going to No, again
But
it will
still in
not
this
be.
case,
Again,
it
it
will
will
be
be a
less than
subset.
A cross
Yeah,
B.
yeah, it will be subset. But yeah, your example was correct. If we take a singleton set,
Yes, ma'am.
if we take a single set, then the cardinality will be actually. So it is basically less equals.
But ma'am, it won't be a graph, right?
Why? Like it will be a point, right? So gamma of f is just collection of this point. Now, if we have one point in our domain and one point in our codomain, then we have no other option rather than one point, right? Then this point will be the graph of this function f. Okay.
Okay, ma'am.
Yeah.
So if you want both options to be correct, that it is less than or equal to A into B,
Yes.
and it is also subset of A.
Yes. The cardinality will be same as A, because for each x belongs to A, we will find some corresponding point x fx in the set of gamma x, right?
So it
The
will be
cardinality
equal
will be-
when B cardinality is 1.
Yes. Yeah.
What is that?
So not necessarily every time the cardinality of A and cardinality B are same. So if it is not same, then the third option is definitely not correct. But the second option will be always correct, right?
But in the answer, both options are given correct.
Okay. So A, B are finite. We shouldn't be correct.
Can you say that again? Can you
Was
say that?
F as onto function? F was not onto function, right?
No, they didn't mention anything about
It's
that.
just a function.
Yeah.
If it is not onto, then option C should not be correct.
Option D.
Option D is correct. Option D and option B is correct. Yeah, option C should not be correct if F is not onto function. If F is onto function, then option C will be correct. Otherwise, not. Okay. Okay. Any other doubt?
So if it's in some case, if it's given less than or equal to. So if that is equal to the cardinality of A cross B, so at the same time, would it be equal to cardinality of A?
It can't be.
No.
It can
Obviously.
be when B is 1. That's the only case.
Yeah. When cardinality of B is 1, then it can be same at the same time.
Then
Otherwise, it will be strictly less than. If we have some condition that something is less equals to, then both the condition are under our consideration, right?
are we?
Either it will be less than or it will be equals to. So any one of them can be true.
Wait a minute. If cardinality of B is 1, all the domain gets mapped to one output.
Yeah, so
That,
both will be 1.
that is an onto function.
No problem.
It's
No
like
problem. That will be
constant
a
function.
constant function.
It's a constant function.
Yeah, that will be a constant function. Then the cardinality will be same as the domain and the A cross B also. Actually, A cross B will be then the graph of F.
That's a constant function.
Yeah.
We can in
If the
this case,
cardinality of B is 1, then it will be a constant function.
ma'am, onto function for this case. Ma'am.
If
Sorry?
F is onto, suppose if F is onto,
That will
then
mean
for
A is
F,
equal to B.
yeah, then
Oh, ma'am, that is
no,
one
not
and onto both. When we say equal to
Wait
B.
wait a minute. If it is an onto,
Yes.
cardinality of A is equal to cardinality of B.
No, it has to
No,
be
no.
bijective, then
No.
only
Yes.
that's true.
Yes.
Onto,
If it is onto, then cardinality of B is basically
Less than equal to A.
less equals to cardinality of A.
Yes, ma'am.
Range of the function will do it. A
Yeah.
So if
codominant
you
range
take any y from B, then we will get some x belongs to A
That's okay.
such that f of x equals to y, right?
Fine.
Then this point x comma x, this will belongs to our gamma of x, right?
X comma fxn is itself is a comma b. A cross
This
b.
is basically a y.
Yeah.
This
So
belongs to
A
gamma
cross B.
comma. Corresponding to, like, if we take any point from our set B, then okay, then the cardinality will be actually less
A cross
equals
B.
to the
Yeah. A cross.
cardinality of they will be
Very simple.
equals to the cardinality of, because for any point here B, we can find a corresponding point in this.
Yeah. Correct.
And the cardinality will always be same as A. So from here we can also deduce this.
A cardinality of graph is always equal to the
Same as the domain.
domain.
Yeah.
That's
It's always equals to cardinality of domain. But the function, if the function is 1, 1 and onto, if f is a bijective function, then cardinality of A will be equals to cardinality of B equals to cardinality of graph of it. Okay?
that's okay.
Yeah.
But always cardinality of graph is
Will
equal.
be equal to cardinality of the domain. Yeah. Yes.
It was not defined, it doesn't exist, so it will not be there as a graph.
Yes.
Ma'am, so for constant functions, we can say that the cardinality of the graph is same as the cardinality of A cross B.
Yes. Yeah. Yeah. Sure. For constant function. Because then the cardinality of B will be simply 1.
1.
Actually, this is not the correct way. If you have cardinality of B equals to 1, then you can say the cardinality of this will be equals to cardinality. Then it imply this cardinality of A cross B, but not in the not the converse case. Okay. Not the converse case.
That's true. This is
Like if f is a constant function, suppose f of x equals to c for every x belongs to A. In that case, f is a constant function, right? So there may be 4 to 5 element in B, and all the points of A is going to a single point. Then the cardinality will not be same.
that's a restricted definition of the function itself.
Yeah.
You're
So
defining it.
if f is 1, 1, if f is 1, 1, then this may not imply that graph of f, the cardinality of graph of f equals to cardinality of A cross B. This may not be true.
That is okay.
But if cardinality of B equals to 1, then we have f is 1, 1, and the cardinality of graph of f equals to the cardinality of A cross B. Okay?
So B has to be like a singleton set for that.
Yes. Yes. If f is a constant function, sorry, it will be constant function, not 1, 1. Yes. Sorry. Yeah, so it will be a constant function. If f is constant function, then we cannot imply from that that the cardinality of graph of A will be the same as cardinality of A cross B because of this example, right? Because of this example. But if we have given that cardinality of B is 1, then we can definitely imply it. Okay. Is it clear to you? Or else if you have any doubt in this problem, you can directly ask it now.
It's clear, ma'am.
Thank you. Good. Smart.
So yeah, any other doubt?
Ma'am, please share this document again, ma'am.
I think she's giving a PDF.
You can yeah, I shared a PDF of today's session, and this is basically from my note, so I don't have
Otherwise, also
proper
it's there in the
PDF on it.
YouTube, right?
You can take a screenshot if you want to take the screenshot. I can pause here.
Yes, ma'am. Yes, ma'am. That will be
Yeah,
great, ma'am.
yeah, you can take the screenshot from the beginning.
This is recorded and available in YouTube, I suppose.
Yeah, this is even available in the YouTube, so you can
Watch
like
it any
take
number
the
of times.
screenshot
Ma'am,
from the.
only the last part, ma'am. Only the last part.
Okay,
Just
okay,
now,
okay.
which you have written. Yes, ma'am. This.
WGX.
Ma'am, one question. There was one activity question, like a true or false kind of thing, where the statement was, like, let AN and BN be two sequences of real numbers. And the statement is AN, BN may converge even if neither AN nor BN converge. So it was given as true.
It's a
So
sequence of real number. Okay, and
yeah,
option was.
AN, BN. The consider the following. Okay, I have 1 minute. Let me take the screenshot. That will be easier.
It will be better if you can share the screenshot.
Yeah, it will be in the chat. என்னென்ன டெக்னாலஜிலாம் பண்ணிருக்காங்க.
Just share it now.
Screenshot வருது.
I haven't get it yet, so there may be some network issue. Let me wait for.
That's the last one.
Short share.
Really, I didn't know these things.
Okay,
What
because
are
we
you
were
doing?
not used to this online platforms.
Can you reshare it? I can't.
She shared it in a reply of Yashvi. The last image reply.
Okay. I got it. Yeah. So there's A and B are two real sequence. Statement 1 was A and B and both converge to same non-zero number. Then, okay, same non-zero real number. That means option 1 we have A n tends to some n. This is non-zero, belongs to R, and B n tends to the same n. Then n converges to some non-zero. Yeah. Then A and B n will be converges to n square, right? And n is non-zero, so n square will be again some non-zero real number. Option 1 is correct.
Okay. Second
So
one,
the
madam.
second is A n B n may converge even if neither. Okay. So this may converge if neither an nor bn. So we have a example says that an converge.
Sorry, where is the question? I'm not able to see the question, so I can't follow.
This is in the reply.
I already gave it to the chat as a snapshot.
Okay, so we can construct some examples. Suppose if we take n equals to -1 per n, then n is not a convergent sequence, right? This will be this. So this is not a convergent sequence, right?
Yeah.
And
yeah.
again, if you take bn equals to the same. Okay.
Okay.
Then what will be a and bn? It will be 1, right? A constant sequence. This is convergent, right?
Okay.
The sequence 2 also is this can be correct. A constant sequence, that is this for some real number, always convergent. And yeah, the statement 3 is clearly correct, right? Constant sequence is always convergent and converges to the constant.
Yeah. Statement 3 is also okay. Statement 2 was the one where it was a bit confusing.
If you have this type of question from sequence, what you have to do, you have to consider some example. Okay, you have to think about some example, whether you can contradict it or you can justify it. Okay.
Yeah, fine. Got it, ma'am. Thanks.
So yeah, any other doubt? I want you to be very clear with the concept and all the question and how to approach the question, each and everything, so that you can do well in your quiz too. So if you have really any doubt, any kind of doubt, you can ask it. If not, then it's good. Then you can leave. Otherwise, you can ask it. So you don't have any doubt, right? I think you don't have any doubt. If it is the case, then we can end the session now.
Thank you.
Yeah.
Thank you, ma'am.
Yeah. All the best for your next
Thank you, ma'am.
upcoming quiz.
Thank you, ma'am.
Thank you.
Good night also.
Yeah. Good night. Good night, everyone.